geometry students. You should have learned about radicals in algebra and perhaps some in 7th grade. But we know that last year was a non-typical year full of all kinds of interesting learning experiences. So depending on which middle school you came from or which algebra class you came from, there may not have been any radicals covered last year. So we are going to take a minute before we jump into topic 8, and we are going to learn about radicals. Radicals are these square root things. We have the radical symbol, and then we have the radicand, which is the stuff inside there. So hopefully you know that the square root of 16 equals 4. And that is because 4 squared equals 16. So let's look at 2 square root 4. This is actually the same thing as saying 2 times the square root of 4. And since 2 times 2 is 4, then the square root of 4 is 2. So this is really 2 times 2, which equals 4. That means that the square root of 16 actually equals 2 times the square root of 4. So they are actually equivalent. When solved, we get 4 equals 4. Now 4 and 16 are called perfect squares. They came out absolutely lovely and they were easy to work with. We're going to start looking at what happens with numbers when they aren't perfectly like that. So let's take the square root of 20. What we're going to do is we're going to look at what are the factors of 20. The factors of 20 are 1 and 20, or 2 and 10, or 4 and 5. When I look at this list, I see that 4 is a perfect square. That means that I can take the square root of 4 perfectly. So I'm going to actually break this into the square root of 4 times 5. I'm going to take this pair. Okay, the square root of 4 times 5. Now we're going to rewrite as the square root of 4 times the square root of 5. So we can separate those out. Now I see that this is a perfect square here. Oops. This is a perfect square right here. So the square root of 4 is 2. And we cannot take the square root of 5 without getting a decimal. And so when we're dealing with radicals, we want to have exact answers. If we take and punch square root of 5 into our calculator, we are going to get a decimal number, and then we have to round, and then we do not have an exact number. So when we're looking to be exact, we need to leave it in the simplified radical form. So now that I have 2 times the square root of 5, that simplifies to 2 square root 5. So notice when we go back to the beginning and it wanted us to compare these, we actually see that the square root of 20 is equal to the 2 square root 5. Go ahead and work through the try it on your own. Pause your video and come back and check when you're done. Now that you've paused your video to do the try it, I'm going to go ahead and walk through some of these things. So in this first one, we see that 36 is a perfect square, and the square root of 36 is 6. 3 square root 6, if we look at the factors of 6, we can put that over here. We have 1 and 6 and 2 and 3. There are no perfect squares in that, so we know that the square root of 6 is already simplified as far as it can go. So when we're comparing these, they are not equal. The square root of 36 is 6, and the square root of, or 3 times the square root of 6 is already simplified. On the right-hand side, we're going to look at 72, and I went ahead and listed the factors of 72 over to the side. As I look at this list, I'm going to go ahead and find all of the perfect squares. I know that 4 is a perfect square, 9 is a perfect square, and 36 is a perfect square. What I want to do is choose the largest, that's this one right here, of the perfect squares. So now when I break down 72, I'm going to break that into the square root of 36 times the square root of 2. I'm choosing this pair right here. 2 times 36 is 72, so that's breaking that down. The square root of 36 is 6, and square root of 2 is as simplified as we can go. So we see that these two are equal.